So, well, the title of my talk is Distribution-Based Computational Analysis of Makam Music. But while preparing this presentation, I thought that I should talk more about the music because every analysis we do about music, even purely signal processing, has some context. And more I feel like the understanding about music comes before the technology, the techniques. I mean, I think when we talk about the Western approach and let's say dividing things into pieces and you break up the main link between them, there is some parallelism with the concept that we have some technology and we have a tendency to use the same technology for everywhere. So we face a problem, we have some technology and we just use it. But I think the understanding should come first, and in this project, I think we are also going towards that direction. We are trying to understand so that we can develop a better technology. So this is how I understand CompMusic project. So to be able to start with that kind of a perspective, I need to give you more information about the music. That's the reason I wanted to talk more about the music in this talk. And I will summarize at the end quickly the work I have done in the signal analysis. So when we talk about Makam music, it's in fact a large area. This is the best map I could find, but it's not. Don't take it as the correct best map. This is the best I could find. It needs lots of repainting. For example, you would find many Makam concepts in the Balkan regions also. And how far it goes in the east, that I don't know, but there should be many links. So, okay. So there are many definitions for the Makam, but if you would like to, let's say, put just one phrase out of all those different phrases, it ends up to this. Makam is a set of rules for melodic progression and tuning with the target of evoking a specific feeling or mood. So it's quite general, I know, but we have to be general when we talk about music because when we go in details, we make more and more errors, and maybe at this point it's good to be general. So I want to start by playing you some music. I want to let the music speak for itself. And I will play you the early sources of recorded material. Tamburi Cemil Bey is a really important figure for this music still today. Today, the best musicians, when you talk to them, how did you learn music? Most of them would say by listening to Tamburi Cemil Bey and imitating him. Still today, everyone transcribes his music and tries to imitate him. So let me play you one of those recordings. This is called the Çoban Taksim. And actually, this contains some melodies in a makam. You will immediately get it, I think. And also you will hear some sounds from nature. With this example, I wanted to give you an idea at 1915 or 1916, what the music sounded like and what were the influences in that music. Because now we tend to classify music in Turkey, folk music, traditional music, local music, whatever, but it was all together united. But in time, now we have conservatories for folk music and we have conservatories for traditional music at the end. But in fact, they are all together. It's a united, I don't know, space or universe. Let me play that for you. So this is Makam Hüseyini. It's mainly improvisation. Towards the end, we will hear some repeated lines. Those are more dance music, folk dance music type of things. Towards the end, we will hear that also. Maybe I should stop because of timing, but anyway, so this is from 1915. Well, it was the time of change for Turkey, I would say. The change started much earlier, a century earlier. The music started changing about a century earlier. But it was time of radical changes. And I want to also make you listen to him playing the violoncello, so a Western instrument. But you will see that he will play it in a different manner. He was really influential. Today, in international scenes, you would see many musicians from different nationalities playing his compositions. As I said, people imitating to learn music from him. And in today's Istanbul, in various forms, his music is being played. Let me show you an example of that, also to give you an idea about the music of today. This is a Turkish kemençe player with a Greek oud player. So let me play another example, this time on the streets by street musicians. So why do I play all this? Because it's, I think, the source of our music. His recordings have been so influential and still feeding the music. And it's an important source to study, to understand his melodic lines, the melodic progressions, and also the tuning. So I hope in Istanbul we will be presenting a work about his tuning and how it sounds on different instruments. So let's move for the moment. Now the time of changes, I said. So his son was called Mesut Cemil Bey. So you see the time he lived. He continued the tradition, a great musician, a great tambour player. I love his music. And he was the first to introduce the choir led by a chief as a, I think, Western concept. And this changed music a lot. So I want to make you listen to this example from his time, from his recordings. So you see, everyone is singing the same line. So now it's the first time really that a choir sings Turkish music, and it was on the radio. So they had these choirs, and after we can say that there was a boom of boom of choirs. So today we have choirs funded by state. So this is the way they look. You see them today. So you see men and women standing, and they mainly sing the same melodic line. And there are the instruments. Among the instruments, you see some Western instruments, and also you would see the Turkish instruments. So this is the setting today. But this was a really big change in music, because from what I understand of music, in those times being played by a few musicians. Just imagine that music being played by many musicians. First brings you automatically the question of tuning, because you have so many instruments and you have to be in tune to play all together. So it brings its own changes, its own problems, its own discussions actually. So actually, in addition to the professional state-funded choirs, there are many amateur choirs, and this is important. Let's say this has been an important atmosphere for music to live, and you will see why in a minute. Now, let me also show you today's various settings. So music is played in between among friends or families by a few instruments, or you see the folk instrument, the main folk instrument, bağlama, the trio in the middle. Well, it can play both the traditional, or it can play the traditional music containing both folk music and also the classical music. And you would also see music being played in weddings or in wrestling championships. Yeah. So you see on the right that type of music players. And we have in Turkey now lots of classes handled by masters. You see on the left corner the ney players. So there is one master sitting on the left, and there are other ney players trying to learn from him. And also on the right, you see music made for religious ceremonies. So a group of musicians for the religious ceremonies. These are the Sufi dervishes. Let me play a little bit to see how they sound like. Today's choir, state choir. So you see the violins here. It's as if the Western are on the left and the Turkish instruments are on the right. Okay, maybe the religious one also. So the basic of all this is lies on Makam, the Makam concepts. So all what we heard are in a certain Makam. There are certain modulations. Well, the forms usually define where the modulations. Well, I don't know if the word modulation would correspond. Maybe the change, let's say, a change of Makams is better statement. So the form indicates you where the change of Makam should be. But you start with the main Makam, you end with the main Makam, and somewhere in between you can change, and you have some freedom to change if you are composing the music. And let's look at also Turkish music instruments. You see some of the instruments. Let me talk on a few of them. There are some unfretted instruments, fretless instruments. This is a oud. I think most of you all know. This is a fretless, but there is a fretted version of that. This is the lute. So you see frets, and so there is fixed tuning or fixed. Well, these frets are also movable in our case. But you also have these kind of instruments where you have many strings and you have to tune them. And you have also some Western instruments which are adapted somehow. For example, for clarinet, they prefer to use the sol clarinet because of it's easier to sing in that range. And also the system they use have more open holes. They can half open the holes to get inflections of some of the sounds. So let's say this was a kind of a review. But for Turkish music, tuning is always at the middle of the discussion. So it's at the heart of the discussion to fix it or not to fix. That is a real problem. On the right, you see kemençe, fretless instrument. Ney is a flute. You have the holes on it, but you can move always your head to change the pitch. So the pitch can vary. But on the left, you see the fixed fretted instruments, and you have them most of the time within an ensemble playing music, and they have to play in tune, of course. Now let's review quickly what were the tuning theories. So if you go back, you would find the writings of Al-Kindi, and well, they would define music by circles of fifths or fourths. In Turkish, we would name them as devir. And if you follow to find the other written text, you would find many, but repeating always this 3/2 operator, mainly the same tuning being used all over, and they mainly speak of 17 notes in an octave. And actually that comes from the Pythagoras, so that 1.5 operator comes from there. And it's possible, well, the link is most of the time thought of as, let's say, the Greek philosophy had a large influence on the Muslim philosophy. So while taking those writings and reading about that, also those theories about music has been taken. And also we should emphasize here that the success of this repeated theory in representation of the practice is highly questionable. So when something is repeated throughout centuries, we may have a tendency to think that it's true, but maybe the same wrong understanding may have been repeated. So really it's questionable from what we hear of the music, from the recordings, that, well, when I did the analysis, my understanding is, well, 85% or so of the tones can be explained by Pythagorean tuning, but there are some tones or some intervals which are really important that you cannot find really by just going a few several rounds on the circle. So we need to go beyond that. And actually, when you also read these texts, you often see that they discuss the difference between theory and practice. For example, from Farabi, you would find a statement that it says, if there is a difference between the theoretician and the musician, it's always the musician who is right, which we totally agree, I think. But if they name this problem, that means they knew it, that there was this problem of theory. So let's also see a few examples of notation, early notation. So you see from 13th century, this is called the abjad notation. So mainly using letters to describe the sounds. And in 18th century, one of the sultans, Selim III, was a musician, and he really promoted music, and he wanted it to be written. So he has opened the contest of notation. So on the right, you see one of the notations developed for that contest. It's called Hamparsum notation. And so you see how those characters can be mapped to today's notation. And there is an important character, Albert Bobovsky. He has a Turkish name, Ali Ufki. A foreigner stayed in Topkapi Palace in 17th century. And he was the first to write using Western notation, Ottoman music. So he was writing from right to left, as in Arabic, but using the Western notation. And actually, he really helped saving preservation of many pieces, I would say. So now, if he hasn't tried this, which probably, well, for sure has many errors, I mean, this written source is an important source for us to understand, well, at least get some idea about the music of that time. And there is another important figure, Dimitri Cantemir, is a prince, and he had his own notation. You see on the left, this is the notation he had, and he had a treatise. And these texts, Dimitri Cantemir's texts and Alberto Boschi's text are really important sources of the time, the most important sources of the time. So again, let's say some people outside of the Ottoman world write about Ottoman music, and that text becomes the most important source of the music. So, and this has been repeated for many other arts in our culture. So let's come to the 20th century. Beginning of 20th century, time of rapid changes, I say. At that time, well, there was the first state conservatory founded called Darul Elhan, 1917, and they started studying the theory, notation, and repertoire. So the three figures you see on the top figure, three men, they constitute a group of people to write down the repertoire they all know. They all learned by oral education. So they said, we are going to lose this music, so we have to note this music. So they have sit down all together. Okay, of course, there were quarrels, and they were supposed to be more. Some people left because they argued if that was a fa or a fa diez. In that song, one says, I learned from my master as it's fa, the other says it's fa diez, so they quarrel and one leaves. But finally, again, they wrote an important text which constitutes a large part of the repertoire we have today about the previous centuries. So this is, I think this is the point where in our music we are moving from oral to written. So beginning of the century. And let's make a guess. Well, the conservatory has been closed at 1927. Actually, it served for teaching for only 4 years. And could you make a guess when the next conservatory was opened in Turkey? Does anybody have a guess? Well, let me tell you then, 1976. So large gap. So we had conservatories, but only for Western music. So actually, then, well, I should also talk about Sufi tekkes because they played an important role on continuation of music. So the Sufi tekkes, you see ney is the main instrument on the left. And it's interesting that these theoreticians I have shown you, who wrote down the notation and written down the theory, they learned music from these people, actually. But these were also closed and banned in 1925. So no conservatory, no teaching in religion. Sorry? Yes, this is Sufi tradition. No, well, the Sufi tradition, well, now it's somehow accepted, but I didn't follow completely how the progress was. I mean, they were closed and banned, but there is today there's some continuation. What happened in between, I don't really know. So there were some rapid changes really during these times. Let us list quickly. So for a long period of time, starting from 25, no official body for music education for Makam music. Conservatories were all for Western music education. So these people also, at the beginning of the century, they westernized the theory. You will see the notation we use is based on Western notation. And the concepts, some of the Makams, for example, the founder of the theory talks about the main Makam as the Chargah Makam, which is simply a C major scale. So there is some kind of westernization at that point also. And Ottoman music even was banned for a even short period, but you can imagine what has happened at that time. And tekkes were banned. So what was left to carry the tradition? We should ask this question. It was first folk music, because it's the same music as I told you. So regionally it continued. Small circles of people, the radio, amateur choirs, music for everyday life. So people had music in their lives. Anyway. Okay. Now we have in Turkey the Western style conservatory using a Western notation. And you would find many masters teaching outside of the conservatory. So the conservatory teachers are graduates of conservatory, the scholars. So most of the masters out of conservatories, when you talk to them, they're not so happy that, conservatories, they consider conservatory as something for Western thinking. So let me show you the notation used in this century. Today we use it. Everybody learns from this. So to close what I have been saying, the education in previous centuries was oral education. So you would memorize from your master, and the tradition would continue by teaching those repertoire, again by making them memorize. But today, everybody learns from reading this notation, maybe together with a master, but they sing from the notation. Am I using all of my time for music? It's okay? Should I go? Okay, just inform me if needed. So to adapt to the notation for Turkish music, they have invented or taken from somewhere some flat signs and sharp signs. And the theory defines 24 tones in an octave. So 7 more, why? Questionable. To summarize very quickly, it's a combination of Pythagorean tuning. Again, behind that, you would find the Pythagorean tuning. And a way of writing this Pythagorean tuning in the Western notation. So if you would have a piano to play that music, that's the piano you would need on the right. You would have, if I would put all the extra notes on the diez, on the black keys, you would need some extra black keys. So let me define our problem. So we are trying to understand music, but we have to know that today music is based on a westernized theory, and there are patches. Like when they teach music, they use this westernized theory and explain the deficiencies of it. So they would write down a piece and would say, we write it like this, but you should play it a little bit lower, or you should play it a little bit higher. So it's a mixture between written and oral. Actually, when you talk to the master musicians, you would see that they would understand the quality of the musician by how he interprets this notation. So does he correctly lowers or higher these pitches or not? So we don't have any recordings before 1915. If we go back to historical writings, we would see that there are many repetitions and there are many vague descriptions. For us, for engineers, it's really difficult to extract reliable information. I think it's more the musicologists' work to go and give us some information from there. They are, of course, very valuable, really very, we know that, but I think we cannot go into that direction. And there have been many changes in music practice which are really hard to study. So I have been mentioning the fast changes in the beginning of century. Just imagine the bannings, no conservatory, westernization of theory, notation all together, and puts in the social context, puts also the individual variations. I mean, that makes it really difficult to understand it analytically. And the oral education, we can say, is almost broken. In the sense that, well, if we would take oral education, is learning by hearing and repetition. So this is broken. Everybody uses notation with patches, let's say. Yet, music is alive, very much alive, in various forms, and sometimes mixed with other genres today. So now I will move a little bit to the engineering part of the talk. Well, for our project, we have started with reviewing the computational analysis that have been done for Makam music. So we have read the literature, and immediately you see that it appears as if the distributional analysis is the only tool that has been used up to now. So either it's a pitch close histogram or a pitch histogram or some distributions of makams used in different centuries or intervals used by a composer. For example, in conservatories, I have talked to some researchers doing analysis on composers, and you would see them count the number of intervals the composer uses. Mainly that's drawing a histogram by hand. Or somebody would study how many songs are there in a makam or so. These are all distributional data. So unfortunately, we don't have anything except, I could say, just a few, 2 or 3 research which is based on n-grams or so. All other are based on, well, n-grams is also a way of distributional analysis, but there is some sequential analysis inside. So all are based on distributional analysis. So let's go very quickly. Pitch class histograms. How did people use it? Okay, here I'm showing you a pitch class histogram of a makam called Hicazkar. And below you see the names of the notes we have in Turkish music. So for each note we have different names. So for a sol and a higher sol you would have different names. So a sol would take the names rast, and one octave later you would call it a gerdaniye, another name. So some people have used this to study composer-specific characteristics of tunes. So they would take, let's say, from the same makam, lots of songs from different composers. Yes. Yes. Well, no, rast to gerdaniye. Well, a bit less than 2. A bit less than 2. Yes, less than 2. So let's say the tonic is the rast here. This is the higher tonic. Yeah. I think it's clear. The first note, yes. It's called. Well, you always need it as a movement to the tonic. It's called. Well, okay. To make it clear, yes, okay. Traditionally, in centuries, it was all 17 notes. Folk music still uses 17. On the bağlamas, you would find 17. But the theory defined in the beginning of century uses 24 tones. And there is always discussion continuing. And you don't see all of the notes here. I mean, I have taken a figure from somebody else's work. You don't see all of the notes here. I confused you by that. And also you can use this for makam recognition. Let's say you had some MIDI files or some symbolic representation. You can take this histogram and try to match the histograms to find the makam, because you expect to have different distributions. Because this it would immediately give you an idea about the scale that has been used and how frequent one note is used. And of course that would give you an idea about the makam. So you can match the histograms to decide about the makam. And also you can study the similarity between makams, because sometimes there are this discussion if this makam is different than the other makam. They are so close. For example, in education, maybe it's a good information that you know how kind of a hierarchical system or a link of similarities between makams. You can use this for teaching. You can teach by similarities or differences, and this can give you a measure of distance between the makams. And let's move to pitch histograms. So the two talks covered it a little bit. In my past work, I actually did work on pitch histograms, and it was an effective tool to study tuning. We came up with a few ideas I think was useful. I'll just summarize in a few slides, but I don't need to explain what is a histogram. Let me go. But maybe I should tell you about the resolution of the histogram first. Now, you see two histograms on the left and the right. One is using 1/3 of a Holderian comma. Holderian comma corresponds to 1/53 of an octave. So this 53 appears everywhere. I mean, I think the first time by a Chinese before Christ. I don't know the exact time, but it appears automatically if you would use Pythagorean tuning. So at the 53rd, let's say, round, you would come very close to closing the circle. So if you would close it and make it equal tempered, you end up with 53 equally tempered spaces. And these are called commas, well, Holderian comma or Mercator comma. But in Turkey, you would hear the word comma very often, both from the masters, the students, everywhere. And when they talk about comma, it's not always the Holderian comma. Sometimes they try to mean a bit. I mean, when he says lower, well, you should play it 1 comma lower. that means a bit, or 2 comma lower. So this is kind of a descriptive. They use it as a descriptive word somehow. And some would claim it's a Turkish comma, but it's not Turkish, I mean. And I have seen also in books on Arabic music that they claim it's an Arabic comma. Anyway, if you would hear someone talking about comma in Turkish music, that is Holderian comma or the Mercator comma. And okay, the resolution we have taken in our analysis is 1/3 of a Holderian comma. Why is that so? And why comma? Why not cents? Well, having so large literature all talking about comma, we wanted to have some link. And also these people having the word comma always being talked about, at least people can have a better understanding about our figures, we thought. So that is the only reason we have used comma. It's not that we claim comma is the best way to, best measure to quantify things. Oh, okay. Now there is this issue of diapason, or what is the frequency of the drone, let's say. Or let me start with talking about the nave. On the right, you see the flute-like instrument, ney, or nai. This is open on 2 ends, and you see that there are various lengths for these instruments. And the naming of the notes are either, yeah, that's okay, thank you, yeah. So these neys have different names, which explain us about the length. So all these would have different names, and by the name, for example, if you would go and buy a bola henk ney, you would expect it to be either the x centimeters or x plus a few centimeters. I mean, there is a range that it should be. So this, when you play this instrument, when you close all the holes and blow, this is called the note rast or sol. So if you take a smaller instrument, if you take this instrument, close all the holes and blow, it's a sol. Take this instrument, close all the holes and blow, sol. So it's a, let's say, transposable system. And we have the names for that. So Bolahenk, Dawood, Mansur, all these are names for these positions in transposition. And you would see that, well, there are some measures like length and diameter within some range. So these are not precise in frequency, but they appear in between a band again. And so we should keep in mind, notes are related more with fingering, the namings of the notes, not the exact frequency. But what matters is, of course, the intervals between the notes. Now, when we started thinking of pitch, we should talk about the sources of variation of pitch. So there is always the freedom of the player to play a certain pitch, a bit lower or higher. And also there are regional variations of intervals. And if you would go and buy instruments, if you would get a kanun, which is the instrument with lots of strings, and the ney and the tambur, you would see that the way they are constructed and they are tuned are all different. For example, kanun is interesting. Today's kanun players, most of them, they tune their strings with the Western tuners. They use the Western tuners. And then, if I would go very quickly, up to the back. Where was the figure of that? Sorry. Yes. So, on the left, well, on this part, you see mandals. So, little things to change the tuning of that string. So, you first tune to the Western, and then you change it a little bit to the right, to the left, to get the correct tuning. But this ends up in this. So, you can put a fixed number of mandals here. So, you have a certain resolution. So, first by tuning the strings to 12 notes in the Western scale, you divide it into 12 tet, and then you divide it into several other pieces. So let's say by 6, then it becomes 72 tet. So there is some kind of, well, the tuning mentality for the moment is close to that. But they would use their, let's say, ears to play the tunes at the end. But this is to say, when you take a kanun, a ney, or a tambur, the physics are different. In ney, this is a flute, you would open holes, and the diameters of the holes and the placement on the tube would change. On the other, you would have a precise, let's say, a dividing of the octave into short positions. In tambur, you would see that certain locations you wouldn't see so many frets, but in certain locations you would see many, many frets. So all have different approach to tune the instruments. And okay, let me skip this part, sorry to include it. So when we look at the number of notes, so in the previous centuries we had the 17-tone system, then came 24-tone, and if you follow the literature, it seems to increase. It seems difficult to come up with something that can explain everything, that you end up approaching to infinity maybe. So this is 79 tones in an octave is a proposition at 2009. Now, so to start signal processing with the histograms. Now this is a pitch histogram. So this histogram can be played with a short flute or with a long, well, let me correct myself, with a short ney or a long ney. What would it change? If it's a shorter ney, it would have higher frequencies, so it would shift to the right. Or if it's a longer ney, it would be to the left. So to start the analysis, we need to find the frequency of the drone or the reference frequency. Here, by visual observation, you can see it here. So this is the leading tone. This is the tonic, and the rest of the scale you can see. And now, if you want to do automatic processing, you need to find this automatically. And can you do that? Yes, you can do that, and really very high quality. Imagine you had a template for the Makam. Imagine you had a histogram, which is obtained from a large group of recordings, which you can shift to match this histogram. And you shift this histogram and try to find the difference. And the point where the difference is minimum, you see that they would be matching as my fingers. So at that point, you can say, okay, this is my tonic. Yes, yes, it's a normalized one. Yeah, both of them are normalized. Because this may be a short tune or a long tune. And also this is, yeah. No, well, I will show you that we, let's say, first perform this operation to learn. During the learning process, we also use this matching process. Okay. So at this moment, let's assume this is given, and I will explain how we get it. But if it's given, just shifting it, finding the difference, could give you the tonic, and also could give you an information about the Makam. Right? So it can be used both for tonic detection and Makam recognition. The sequence, normally it matters. I mean, it's an important part of the Makam music, the melodic progression and everything. But, well, this is just a feature. I mean, this is one feature. Pitch histogram is one feature. And it can help us to recognize it. But we need features which includes some progression, some information about progression. Yes? Yes, the phrases are different. Well, actually, this is a debate. We have to talk a lot about this. There are specific, let's say, melodic phrases that you would identify immediately with Makams. But there are phrases that you won't be able to decide. In Makam music, progression is somehow taken in a larger context. Well, there are two resolutions. One in a larger context, so where you start and where you end within the piece in a larger sense, is one, let's say, this is one aspect of the melodic progression, and the other aspect is the small, just melodic lines. So the melodic lines, one melody or one phrase can give you a taste of a makam. But that taste can be used in a piece in another makam. Okay. So this idea was also used for Indian music. Well, there is a paper by these people being reviewed for the moment. But well, they tested to find the drone frequency, and they said it was working. So some concepts are parallel. So this is the idea of being, well, this is the reason we are here, I think. And how do we find those histogram templates? So this thing I have shown. How can we get the learning? So very quickly, let's say you are given n recordings from the same makam. You want to train your system. You get the histogram, and then just at the beginning we start with the theoretical system. So the system defines some intervals, and we build a template as Gaussian mixtures, a theoretical template, not the real one. So this is a histogram template, and we align all these recordings with this theoretical template, and then we throw it away. We sum all these, and we get another, let's say, summed up template. So then we throw this one away, and we put it in a loop. And in a few loops, this converges, and at the end, you end up, well, the idea here is just to be able to transpose all with respect to each other so that you have the same drone frequency. Then you can sum up. So this, for example, why use the system if there are problems? You will see in a moment that the problems of the system is, well, they don't specify tones just randomly. I mean, the tones specified are at close regions. And let's say out of 8 tones, 6 would find very good matches, 2 wouldn't find the good matches, but still the histogram match is good in general. So as a start, using this has no harm, but if you are not content, you can use one of the recordings from here and just make the transposition with respect to this recording. But let me show you how we can start from the system and constitute. Sorry? Well, just to get a histogram, just to get this shape. Yeah, just to get a histogram. Because in theory, we are just given these values. This is in Holderian commas. So 0 is the drone frequency, let's say, relative frequency. And 53 is the octave. So you have these steps in Holderian commas. This is a Hijaz scale. So the scale would show up like this in the histogram. And then if you would just try to align it with a real recording, you would see this is full automatic. You would see that they would match. So even if I had this in the theory a bit to the right or a bit to the left, this would match in general. And if there is a little bit of mismatch to the right or left, you can, well, after you find that it's around this region, you can find the peak of this place, and you can correct small errors. So let me show a few examples. This one is okay, Husseini Makam. The one on the right is Rust. For example, this one is close to C major scale. The whole tone, half tone, whole tone, half tone type of thing. And here in Makam Sabah, we have some intervals which do not match the theory. For example, here you see this 4th tone or 3rd interval being higher than what's said in the theory. Still, the match overall is fine enough. And actually, this kind of matching gives us an idea or a method for us to compare theory with the practice. So here, on this figure only, you can see how theory and practice have differences. Well, you can get some information at least about it. So we tested this tonic detection algorithm both on synthetic signals and on real signals. On synthetic signals, so you starting from MIDI, you synthesize signals and then you try to find out the number of falsely detected peaks. So there we have used different methods to find the difference of histograms. So the idea is to, when you shift the histogram, you find the difference between histograms. So that can be done in different ways. You can find the cross correlation, city block, blah, blah, lots of things. But you see that if you would use a simple subtraction of the histograms and summing up the absolute value, you would see that for the synthetic signals, you don't make any errors out of 150 songs. And on real recordings, I have labeled the tonic myself by hand. And on 118 songs, there was only one error that system made. The Makam was wrong. Well, let me tell you, the Makam recognition works around 65 to 70%. But well, when it makes an error, it usually confuses similar Makams which use very similar scales. So in that case, you don't make an error of tonic detection, but you make an error on Makam detection. Yes, Makam detection. So this is quite good, I think, and it can be used for other music. So given this tool, we said, okay, let's take recordings that are considered by the masters are the best recordings to represent Makam music. So we have studied theory-practice mismatch of 9 most frequently used Makams, which corresponds to almost 75% of the repertoire. So we have taken recordings from only very famous people, all accepted, and then we have found, well, we have extracted these averaged histograms, and we checked out with the Western scale and with the theories. So these lines are the Western, well, let me not call Western, this is wrong, the 12th system. So this is the 12th system. Plus, you see the theories here. The 24-tone system for this Makam defines the tones to be at these positions. The second system, the theory, defines to be at these positions, and the third system, fourth system. So you can have many theories, the 12th tone and the histogram. So on one figure, you can get an idea about what kind of scale people use, and you would see that some of the notes are really out of the 12th system. And well, this you can get if you send me an email. I can send you these figures. So now one of the things we miss here is, well, we have only one histogram, but the pitch changes on ascending and descending lines. So one could also study using this information, the ascending and descending lines. Okay, sorry. So what do I mean by that? So you would see some kind of glissandos, sometimes not really glissandos, but just a tendency to lower the notes. Okay. And Makam recognition, I already said, well, it works. Well, this is the F measures. You can look. These are the classes. These are different Makams. For each Makam, let's say, the success rate are listed here. And the errors are, for example, Husseini and Ushak. They are confused. They use almost the same scale, so they are confused. So the histogram-based Makam detection would confuse Makams that use similar scales. Okay. So let's talk about human performance. Usually in machine learning, people talk about human performance. So we don't. Well, one of the difficulty in computational analysis of this music is we need some information from other disciplines, for example, the perception discipline, or for example, nobody has measured human performance on tuning or on recognition or Makams or anything. So, well, we lack some information to study some of the concepts. But let me just close this by, well, professional musicians, they wouldn't miss Makams most of the time. They would immediately find them, and most of the time, in fact, by phrases. So normally when they teach and when they describe it on a larger scale. They say it should start around here and then it should go somewhere there. But you would see them, they decide about the Makam just within several phrases. But also, an average Turkish listener should be around by chance. Most of the people don't know about Makams, or they don't understand which Makam they are listening to. So just to be able to close quickly, let me show you a few melographs of Taksims. So this is a solo improvisation by Ney. So this is all from the same Makam. And you would see that they tend to have an overall progression. So they tend to start around the same region, you see. They all start really from the same region. And they would go down to this point to show the tonic. The tonic is here, in fact, 0. And then they would go up and play in this region, and then come back down here. So, well, some of the things that are described in text, you can see over there, but this is open to discussion. Either these people read and repeat this information and try to obey these rules. So does the theory impose this information? Or it's already there and put in written form later? That I don't know, but at least we can say in today's recordings, in improvisations, we can try to find out some overall melodic progressions. So we can try to do some signal processing for that. So, okay, my last presentation. Sorry, I think I used lots of time. So I'm at a point to stop doing distributional work because we have done enough, I think. Well, I have done enough just to help the work in CompMusic project when needed. And I would like to move towards temporal, and I think, and I'm sure, we will benefit a lot from the Indian team's works of the work here. All of the discussions we had before my talk, you would find very similar discussions in Turkish music. And we have so much to learn from you. For example, the ornamentations. We don't have classes of ornamentations, and how to teach them, the methodology is somehow vague. I see that at least there are the concepts of gamakas, there are different classes, there are ways of notating them. So we can really benefit from this information, and I'm sure we will benefit a lot from the signal processing methods you will be developing. So I'm really happy to see all these discussions and see all those common points. So, well, our current target is to study melodic atoms and overall progression. Well, to be complementary, we are currently working on symbolic domain. So starting from the notation, can we understand the melodic phrases, and can we develop some technology for that? Because you will be already developing the signal processing, the audio processing part of that. Maybe we could provide the symbolic data processing part of that. So thank you all for your patience. Sorry for the time.